Find ordered pairs x comma y. Find ordered pairs x comma y of integers such that 1 by x plus 1 by y equal to 1 by 6. The technique is pretty similar to what we have done just a bit earlier. We will consider in this case like what we have done. First of all, cross multiply. I'll first do the LCM to get x plus y upon xy equal to 1 by 6. Then I just consider 6x plus 6y equal to xy upon cross multiplication, which I simply write down in this manner. And the idea or the technique is to simply add the square of 6 on both the sides, 36. I'm going to add in this case xy minus 6x minus 6y plus 36. Now the left side could be factorized. We can take common x to get y minus 6 and minus 6 into y minus 6 equal to 36. And so we have a factorized form x minus 6 into y minus 6 equal to 36. Now the task is to factorize 36 in every possible way, pairs. So we get 1 into 36 or minus 1 into minus 36, or we have 2 into 18, 3 into 12, 4 into 9, and 6 into 6. And the corresponding negative parts as well. We get minus 1 into minus 36, minus 2 into minus 18. I have minus 3 into minus 12, minus 4 into minus 9, and minus 6 into minus 6. Definitely x and y cannot be 0, so I can rule out the last pair actually, because if I consider the last pair of minus 6 and minus 6, this will give us x equal to 0 and y equal to 0, which is not allowed actually. So we can simply cross out this part. This is not needed. It will not yield any solution actually. But once we have this, after that, the usual idea is to, compare pairwise. For example, if I take up, it will be obviously quite cumbersome to solve for everyone, but definitely you can find it out because for example, if I assign x minus 6 as 1 and y minus 6 as 36, this will give us the pair x equal to 7 and y equal to 42. This gives us a pair of 7 comma 42. You know. Obviously, I can interchange them as well. So this will give us two solutions. This will give us two solutions, two solutions, two solutions. This will give us only one solution because interchanging them will not be different. This will give us two solutions. That will be two. That will be two. This will be two as well. So problem solutions, if I count, I get 2, 4, 6, 8, 10, 12, 14, 16, and 17. There are 17 such pairs actually. If I just count all of them over there, it will be cumbersome to write all of them, but we can definitely write down. For example, we have already got 7, 42. So let us list possibly all the solutions over there. What do we get? The pairs. We have got, first of all, 7, 42. Then definitely we can interchange to get 42, 7. We have got already two of them. If I take x minus 6 equal to 2 and y minus 6 equal to 18, what do you get? I get 6 plus 2, 8. Basically, I have to add 6 on both the sides of that. 6 to 8 comma 26, and therefore they reverse 26 comma 8. Then I shall have 3 plus 6 is 9, and 12 plus 9 is 21, and 21 comma 9. When you get 4 plus 6 is 10, 9 plus 6 is 15, or 15 comma 10. Then we have 6 comma 6, that will give us simply 12 and 12. Now coming to the negative side, minus 1 plus 6 is 5, minus 36 plus 6 is minus 30. So 5 comma minus 30, and obviously I can reverse minus 30 comma 5. If I consider minus 2 minus 18, then what I have, minus 2 plus 6 is 4, minus 18 plus 6 is minus 12, then the reciprocal minus 12 comma 4. Then we have, if I add minus 3, so I get minus 3 plus 6 is 3, and minus 12 plus 6 is minus 6. So we have got minus 6 comma 3. Then we just sign minus 4 plus 6 is 2, and minus 9 plus 6 is minus 3. So we have got this one. And finally, minus 4 plus 6 is, oh, that is what we have taken already. And the last will not give us any solution. So you can see 1, 2, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 what we have. In general, we can actually look at the number of solutions by looking at what a denominator is actually. It all depends on what a denominator is. This one, the square of that. If your denominator is n, for example, then I'll have to factorize n square. So the way that I could write on n square in number of pairs, isn't it? For every such pair, we get two solutions, except for one. If it is a, I mean, obviously it will be always a perfect square, n square into n square. When n square is n into n is always a perfect square. So for that case, I'll always get at the end n cross n or n times n. That will give us only one solution, and minus n comma minus one will not give us any solution actually. So basically, those two will give us one possibility, and apart from that, every other possible way, write on n square into a pair of factors, will give us two solutions over there. And obviously assigning them to the negatives as well. So that is how we can just solve such equations.